So hello students, welcome back. Today we will understand carbohydrates and we'll just review the MCQs and objective questions of carbohydrates. So let's begin. So let us begin with the multiple choice question. First one is carbohydrates are mainly composed of which of the elements? So the word itself tells you carbohydrates. So carbohydrates nothing but carbon, hydrogen and oxygen. So option B is the correct option. Okay, next one is which of the following is the simplest carbohydrate? The option given are glucose, fructose, glyceraldehyde and sucrose. So glucose, children, the molecular formula is C6H12O6. Similarly, fructose is also having the same molecular formula, and sucrose has C12H22O11. And let us see glyceraldehyde. Glyceraldehyde has the molecular formula C3H6O3. So it is having a very simple structure. If you see aldehyde group, okay, then CH2OH, OH and H. So this is the structure of glyceraldehyde. So this is said to be the simplest monosaccharides. Now the next one is glucose and fructose are dash. So the options given are epimer, anomere, isomer and enantiomer. So these are isomers. Glucose and fructose are isomers of each other. Okay. Next is the general formula of monosaccharide is dash. So here if you see monosaccharide formula C3H6O3 means if you compare with this formula, it is simple formula, that is C3 is N suppose. So 3 double of it means H should be 2N, because hydrogen are double of carbon and oxygen are same like carbon. So this is the general formula for monosaccharide. So the option correct is A. Now which polysaccharide is the storage form of carbohydrates in plants? So you have to explain that, you have to tell which is the carbohydrate, which is the polysaccharide which is stored in the form of carbohydrates. So we know that potato is the best example for this. In potato you will find starch is stored. So option C is correct option. Okay, let us go to the next one. Now the next question is which of the following test is used to detect the presence of carbohydrates? So children, in the laboratory we perform Molish test to detect the presence of carbohydrate. Okay, so next one is which of the following is reducing sugar? So among this you have to find out which is the reducing sugar. You know there are two types of sugar, non-reducing and reducing. So which sugars which can be reduced here? Option B is the correct option, where lactose will be reduced, whereas sucrose, starch and cellulose, they are said to be non-reducing sugar. All other are non-reducing sugar. Okay, so this can be also asked in the exam in the way that following which is the non-reducing sugar. So you should know cellulose, starch, sucrose, these are non-reducing sugars. Okay, now next is sucrose is composed of dash. So sucrose is having which two ingredients? The option they are given is glucose, then gala-lactose, glucose fructose, glucose ribose and glucose. So obviously option B is the correct option, that is glucose and fructose. Sucrose are composed of glucose and fructose. Now next one is which enzymes hydrolysis lactose into its monomeric units? So here hydrolysis, lactose when they hydrolyze, they are going to convert into small unit. Monomeric means small unit, single unit. So which is that single unit? So the lactose will convert into lactase. Okay, after hydrolysis from enzymes, lactose gets converted into lactase. Now the next one is the term mutarotation refers to dash. So here mutarotation, basically it is conversion of alpha and beta anomers of the sugar. Okay, alpha anomer gets converted into beta anomer. If this conversion is taking place, such rotations are called as mutarotation. So, and they are interconversion. So alpha can be converted into beta and beta can be converted into alpha. So option B is the correct option. Now let us go to the next one. So the next one is Benedict test is used to identify dash. Basically Benedict tests are used to identify the reducing sugar. Next is which of the following carbohydrate does not give the positive test with the iodine. Iodine basically is used to detect the starch. Okay, and when iodine reacts with a starch, it will give blue black color. We do the titrations of these in the lab, blue black color. So basically you will find that starch is present in amylose, then glycogen and starch. Only cellulose is the one which will not show the positive result. Now next is chitin. Chitin is a polysaccharide found in, basically they are found in insects, that is exoskeletons. Okay, so option B is correct one. Then next is the DL and L form of sugar refers to. So many times we write D glucose, okay, then L glucose, then D fructose, L fructose. What does this D indicates? So D indicates here, it refers to what? The position of hydroxyl group on the carbon. That is one carbon which is just second last carbon. Okay, from the terminal, the second last carbon, where the OH group is placed, whether it is on the right hand side or left hand side. If it is on the right hand side, we denote it by D. If it is on the left hand side, we denote it by L. Okay, so this way we can denote the sugars with DLL form. Next is which of the following is an example of ketohexose. So ketohexose is the hexose, so it is a ketone having C double bond O group, that is keto group. Hexose means 6 carbon chain having keto group. So basically if you see the options, fructose is the one which is having 6 membered ring with ketone group on the second carbon. Okay, so let us go to the next one. Epimer differ in configuration at dash. Epimers is what? A carbon atom other than anomeric carbon. Okay, a single carbon other than anomeric carbon, we refer it as epimer. So the epimer differ in C, C is the correct option, a single carbon other than anomeric carbon. Next is Kiliani-Fischer synthesis is used for dash. So basically Kiliani-Fischer synthesis is used to increase the carbon chain of the sugar. So option B is the correct option. So if you want to increase the carbon chain of the sugar, you are going to use this synthesis. Kiliani synthesis involves dash as an intermediate. So basically in Kiliani synthesis we have seen in question answers that it is intermediate formed is cyanohydrine. Okay, cyanohydrine, that is C and hydrine CN, which will have OH group also on it. So it is cyanohydrine. Then next is reduction of D plus glucose with sodium borohydride gives dash. Reduction of D. D is your second last carbon, OH group is on the right hand side. When reduced with sodium borohydride, basically it will give you D configuration and sorbitol is the answer. So for this children, you should know the chemical reactions, or you can solve them and see what is the product you will be getting. So the option is D sorbitol, and this is one of the very important reaction of glucose. Okay, this reduction of glucose is very important because many a times it is asked also to complete the following reaction, or what happens when D-glucose reacts with sodium borohydride. So the correct answer is D sorbitol. Then next is which is used to oxidize glucose to glyconic acid. So now this is oxidation. So which compound, which reagent you will be using to oxidize glucose to glyconic acid? So it is bromine water. That is, again these are based on your chemical reactions of carbohydrates. If you know the chemical reactions of carbohydrate, then you can solve them. Next is oxidation of glucose with nitric acid produces dash. So when you oxidize glucose with nitric acid, you are going to get the option B. Okay, you will get an acid. Then next is third one, 23rd one is dash reagent selectively oxidize only aldehyde group of glucose. So selectively or selective oxidation can be done using bromine water. Option A is the correct one. Aldehyde group of glucose will be oxidized selectively. Then when glucose is treated with periodic acid, again oxidation. Okay, periodic acid is used as a oxidizing agent. So it undergoes oxidation and cleavage. Option B is correct option. So whenever you see the reagents, it should strike that what that reagent is going to do on your starting material. So here glucose we are treating with periodic acid. Obviously periodic acid is oxidizing agent, oxidation will take place. Next is, what is the product when glucose is oxidized using Fehling solution? So when glucose is oxidized with Fehling solution, it gives you glyconic acid. So these are all, you cannot by heart them, but you should know the reactions. If you know the reactions, then you can recall them. Next is, when the glucose is treated with methanol in the presence of dry HCl, it forms dash. So here we are going to react methanol, that is CH3OH group. Okay, here CH3OH group, if you react with glucose, what is the product they are asking? So you will get a methyl glycoside, which is option B. Option B is the correct option. Which of the following reagent oxidizes glucose to glycuronic acid? Glycuronic acid, that is the option C is the correct one, Benedict's reagent. Okay, so let us go to the next one. Next is, in methylation of glucose, dash reagent is used. Now here it is methylation. Methylation is addition of CH3 group to the glucose. So basically in the option given you will find there is no methyl sodium B option sodium borohydride, C is nitric acid, D is bromine water, but A is methyl iodide plus silver oxide. So the option A is correct because we are doing methylation, means addition of methyl. So the reagent should contain methyl group. Next is Ruff degradation is used for 2 dash. So they are saying degradation. Degradation means कम हो रहा है. Okay, Ruff degradation will be used to shorten the carbon chain. So Kiliani synthesis is used to increase the carbon chain of the sugars, whereas here Ruff degradation will be used to shorten the carbon chain. So option A is correct. Next one is oxidation of D-glucose with nitric acid results in formation of dash. So here, with nitric acid, when D-glucose oxidizes, it gives you aldaric acid. Okay. Then 31st one is dash confirms the presence of free anomeric carbon in glucose. So which is the test which is going to confirm that there is a free anomeric carbon present on glucose? So that is Fehling test. Okay. The next is epimers are compounds that differ in configuration at dash. So epimers are those compounds which differs by what? Only one specific carbon other than anomeric carbon. So option B is the correct option. So these are your basically multiple choice questions from carbohydrate lesson. Now next we will see true or false. Okay, in true or false, the first one is, in Haworth projection, the alpha anomere has OH group at C1, that is first carbon, pointing upwards. So this is false. In Haworth projection, basically Haworth projection is for example, for five membered carbon, this would be the Haworth projection. Okay, so here means a cyclic actually, and if the carbon which suppose this is your first carbon, then if the OH group is upward, okay, then we will call such as not alpha but beta. If OH is upward, then we call such projection as beta and beta isomer or NMR. Okay, and if it is downward, then we call it as alpha. So here this is this way you can see, or one example I can show here before we. So let us see one example only so that it will be clear how the alpha and beta NMRs we can show in Haworth projection. So let me take the example of, wait, my pen, I think, yeah, it is writing. So here if we take alpha D glycopyranose, so pyranose is 6-membered ring. So here if you show the Haworth projection, it will look something like this. O 6-membered ring. Okay, then you have to represent the carbon hydrogens, H, OH, then your H, here will be your OH, then your OH, H, and this is called as your carbon, which is going to be C1, after oxygen the first carbon. So here this is your C1 carbon. In this C1 carbon, if the OH is above, then it will be beta, and when we are writing alpha means OH should be down. Okay, so if OH is down, then we say it as alpha, and beta indicates that OH is upwards. Okay, this way. So this is how you can recall the Haworth projections. Now next one, let us move to the next one. Next one is, so the first statement is false. Now second is Haworth projection represents, here the MCQ number, okay, doesn't matter. Haworth projection represents the cyclic structure of carbohydrate. Yes, true. This is the example. Okay. The next is D-glucose is an aldohexose, while D-fructose is ketohexose. So this is correct, true. Glucose are aldose and fructose are ketose. Okay. The next is oxidation of D-glucose with bromine water gives dash. Now in the previous fill in the blanks we have seen that oxidation of D-glucose with bromine water gives glyconic acid. So this is true statement. Next is D-glucose and D-fructose are epimer of each other. So they are false. They are not epimer, but they are isomers of each other. Okay. So let us understand what is the difference between epimer and isomer. So basic difference between the epimer and isomer is, isomer definition you know. What is the definition of isomer? Isomer has same molecular formula but structural formula is different. Whereas epimer is such stereoisomers which differ only because of one chiral center's configuration. Okay, epimer is what? Only one chiral center configuration is differed. Then we call such isomers as what? Epimers. So basically glucose and fructose, they don't only means they have totally different structural formula. So they are not epimers, but they are um, isomers, constitutional isomers. The next is oxidation of D-glucose with nitric acid produces glyconic acid. So this is false, because we have seen this D-glucose with nitric acid will not give you glyconic acid, but it gives you glucaric acid, because both aldehyde and primary alcohol is going to get oxidized with nitric acid. So here basically you can see the statement is given here, the true statement. Nitric acid oxidizes both aldehyde as well as primary alcohol group on glucose to give you glucaric acid. Okay, so the sixth statement is false. Okay, let us see the next one. Well, degradation method is used to increase the carbon chain of an aldose. Obviously, the word itself is telling you that it is degradation. So, carbon chain cannot increase, but it can reduce. So, this is a false statement. Next is Kiliani-Fischer synthesis is used for chain lengthening of aldose. So, this is true statement, because we have even question answer session we have seen that Kiliani synthesis is used to increase the carbon chain in aldose. Next one is fructose react with Fehling solution to give positive test because it rearranges into glucose under alkaline condition. So this is true. Fehling solution, what it will do? It will rearrange to convert into glucose. Fructose gets converted into glucose, means ketoaldose get converted into aldohexose. Okay, ketohexose are converted into aldohexose. So ketone has been converted into aldehyde group. So this is correct statement. Next is epimers are stereoisomers that differ in only configuration at one of the chiral center, excluding the anomeric carbon. So this is true. Okay, what are epimers? This is the definition of epimer. Epimers are stereoisomers that differ in the configuration only at one chiral center other than the anomeric carbon. The next is the mutarotations of glucose is the interconversion of alpha and beta anomers in aqueous solution. So this is true. Mutarotations are what? Interconversion of alpha and beta anomers. Next is amylose and cellulose are both unbranched polysaccharides. So this is very much true. Amylose and cellulose are unbranched polysaccharides. Then the next one is sucrose is a reducing sugar because it contains free anomeric carbon. So this is false. Okay, the statement is false because sucrose is a non-reducing sugar. In the first fill in the blank only we have seen the sucrose is non-reducing sugar. Okay, so both anomeric carbons are involved in the glycosidic bonds. So here I think here we finished the MCQs and objective type of questions of carbohydrates. So stay tuned. Do watch my other videos which I have uploaded for stereochemistry, and there will be more videos on carbohydrates also. So if you want anything from this chapter, you can just comment below, like and subscribe. Bye till then.